Hi students, good morning to all of you. Today we are going to discuss about the topic of all-day efficiency of transformer. All-day efficiency of transformer. What is the topic we are going to discuss today? All-day efficiency of transformer. So what is all-day efficiency of transformer? Why we are going to study this topic? First, generally we know that efficiency is nothing but it is defined as the ratio of output power to the input power, the ratio of output power to the input power. So these calculation, these type of power efficiency calculations is not given the true measure performance of the some special types of transformers. What is that special type of transformer? That special type of transformer is the distribution transformer. Distribution transformer. Here, in a power system, the transformers are two types of transformers mostly. One is the power transformer and next one is the distribution transformer. Next, what is distribution transformer? What is the main purpose of distribution transformer? What is distribution transformer? Distribution transformer. The main functioning of distribution transformer is it also changes the levels of the voltage from one level to another level. But these type of transformers are used or given the service in residential consumers and commercial consumers. Residential consumers and commercial consumers. And one more important point, the load, the load on such type of transformers are vary continuously during the whole period of the day. In that type of transformers or distribution transformers, the load capacity can be varied continuously during the whole period of the day. And next one, most of the period. So here, most of the period, these distribution transformers are working at only 30 to 40% of the full load capacity only. So here, for example, the distribution transformer having the capacity is 30 kVA. Having the capacity is how much? 30 kVA. So it is operating at the full load capacity of only 30 to 40% is nothing but 12 kVA only. 12 kVA only. And next one, here the transformer having the two windings are there. What are those two windings? One is the primary winding and next one is the secondary winding. So this distribution transformer also having the two windings. What are those two windings? Primary winding and secondary winding. So you know that define primary winding. The winding which is connected to the source, that is we call as primary winding. Define secondary winding, the winding which is connected to the load, that winding we call as secondary winding. So here in distribution transformer, the primary winding of the distribution transformer is always connected to source, is always connected to source, that is the rated voltage. The primary winding of the distribution transformer is always connected or energized at its rated voltage per 24 hours, for 24 hours, and to provide continuous supply to the consumer, continuous supply to the consumer. The transformers which are connected in our streets or lanes, those transformers are distribution transformers. They always supply the energy to the consumer 24 by 7 into 365 days. 24 into 365 days. So every hour or every minute, they always continuously supply the energy to the consumer. So that's why the primary winding of the distribution transformer is always connected to the source, is always connected to the source. Why? Because to supply the energy to the consumer. And next one, due to connecting the primary winding of the transformer to the source continuously, the core here, the core losses, the core losses which depends on the voltage. The core losses which depends on the voltage. So due to that, here the primary winding is continuously connected to the source voltage. The core losses are more in the distribution transformer. The core losses are more in the distribution transformer. And next one, what about the copper losses? The copper losses are depends on the load condition. The copper losses are depends on the load condition. Just now we discussed the full load. So the distribution transformer is operated up to only 30 to 40% of the full load only, not 100% of the full load. Why? Because The load on the distribution transformers are vary continuously. The load on the distribution transformers are vary continuously. For example, a day consisting of how many hours more? 24 hours. A day consisting of how many hours? 24 hours. So in these 24 hours, we are dividing into the morning, and next one is the afternoon. Morning and afternoon, and next one is the evening, and next one is the midnight. Next one is the midnight. See that here, the most of the consumers are switch on their home appliances at evening time only. At evening time. And next one, what about the morning time? Very less amount of loads are switch on. That is the components which are used in the kitchen appliances. And afternoon, coming to afternoon point, here also some of the industries, small scale industries or medium scale industries, they are connected. And next one, midnight. Midnight are very less load, very less load. So here the load in a day or 24 hours, the load on the distribution transformer does not constant. It should vary, depends upon the type, depends on the day, morning, afternoon, evening, and midnight. So due to variation of the load, here that is the load on the distribution transformer is not constant. Is not constant. So that's why. And next one, for no load condition. Under no load condition, here copper losses are negligible. Under no load condition, copper losses are negligible. So when we consider the copper losses at full load condition, when we consider copper losses at full load condition or short circuit condition, so these type of calculation of efficiency does not give the correct measurement to the distribution transformer. So that's why to find out the efficiency of the distribution transformer, we are not using the output power by input power. Here, the output power of the transformer can be calculated. Here, in distribution transformer, the output power of the transformer is calculated in kilowatt. It is calculated in kilowatt hour. Why? Because the energy is measured. The unit of electrical energy is kilowatt hour. The unit of electrical energy is the kilowatt hour. And next, come to the point. So that is about some important points of the distribution transformer. What is distribution transformer? The transformer which is given the service to the residential consumers and commercial consumers. That is we call as a distribution transformer. That is we call as a distribution transformer. And next, see that what is the definition of distribution transformer? What is the definition of distribution transformer? That is the here, definition of distribution transformer is the transformer which gives the service to the domestic consumers, commercial consumers, that is nothing but residential consumer. And next one, the output energy of the distribution transformers are calculated in terms of kilowatt hour. In terms of kilowatt hour. So define all day efficiency. Define all day efficiency. It is also called as energy efficiency. Very important for a competitive examination. What is the another name of all-day efficiency? Energy efficiency. Define the all-day efficiency, the ratio of total energy output to the total energy input. The ratio of total energy output to the total energy input. See that here in all-day efficiency of the transformer, we does not consider the output power and input power. We are consider the energy output and energy input. Energy output and energy input. You know that what is the expression of input? Input is equal to output plus losses. Output plus losses. And next one. So based on this, here we are finding the all-day efficiency. So all-day efficiency is calculated for which type of transformers? Distribution transformers. Here two types of transformers are there, power transformer and distribution transformer. So power transformer having the calculations of general power calculations, power efficiency calculation. But all-day efficiency is applicable to only distribution transformer. Define all-day efficiency. Very important for 2 marks. Define all-day efficiency. The ratio of output energy of the transformer in kilowatt hour during a day. A day consisting of how many hours? 24 hours. Here, the output power of the transformer, that is the output energy of the transformer is calculated in kilowatt hour during a day. So that's why this efficiency we call as all day efficiency. All day efficiency. And next one, what is It can be again, it can be written as input is equal to output plus losses. What are the energy spent for total losses? How much amount of energy is wasted due to the losses? Is wasted due to the losses. And next come to the point. While calculating the energies of the distribution transformer, all energies can be expressed in watt hour only. All energies are calculated in watt hour only. Okay. Such distribution transformers are designed. So just now we discussed the distribution transformer having the two windings. What are those two windings? Primary winding and secondary winding. So this primary winding is always continuously energized. Due to continuous energization of primary winding of distribution transformers, they have they have more core losses. So that's why we are going to concentrate to reduce the core losses. Okay? To have very core loss are designed. Such distribution transformers are designed to have very low core losses. How is it possible? Very core losses. So core losses are nothing but the iron losses. Core losses are nothing but the iron losses. Iron losses is the combination of hysteresis loss less, and next one is the eddy current loss. Hysteresis loss and eddy current loss. In hysteresis loss, here hysteresis loss is proportional to maximum flux density of power of 1.6. In eddy current loss is proportional to maximum flux density of square Bm square. See that here? Here we are going to reduce the maximum flux density. When we reduce the maximum flux density of both, here automatically we reduce the hysteresis losses and eddy current losses. How is it possible? What is the formula of what is the expression of maximum flux density? V is equal to V is equal to pi by A. V is equal to pi by A. When we increase the area of cross section, then automatically maximum flux density will be decreased. So that's why here, see that here, by limiting the core flux, how we reduce to limit the core flux density to lower value by using a relative higher cross section. By using relative higher cross section is large iron to copper weight ratio. Large iron to copper weight ratio. So that's why these distribution transformers having the low core losses by this design. And next one, the maximum efficiency. When the maximum efficiency of the distribution transformers are occur up to 60 to 70% of the full load condition. So in 60 to 70% of the full load condition, we get the maximum efficiency. So that's why the distribution transformers are designed properly, having the high energy efficiencies can be achieved. Having the high energy efficiencies can be achieved. That is about today. The topic is the all-day efficiency of transformer. All-day efficiency of the transformer. All-day efficiency is calculated for which type of transformer? Distribution transformer. Why we are going to study about this all-day efficiency? The general efficiency does not given the correct measurements for the special type of transformer. What is that special type of transformer? Distribution transformer. Very, very important for 5 marks question and also competitive exam point of view. What is the another name for energy efficiency? All day efficiency. What is the another name for all day efficiency? Energy efficiency. Define all day efficiency. All day efficiency is equal to output energy in kilowatts during a day to the input energy in kilowatt during a. Okay, students. Okay, is it all of you understand now? This topic is the all day efficiency of a transfer. All day efficiency of a transfer. If you have any doubts, can come. Thank you.